Hey everyone, welcome back, or if you're just joining us, welcome to KSSP Podcast. I'm Spencer.
And I'm Katie. Today we're going to be talking about red giants and red supergiants in our series today of the star's life cycle. So, first, I'm going to just go over what different colors of stars mean. So, red stars are the coolest, yellow stars are hotter than red stars, and white stars are hotter than red and yellow. But blue stars are the hottest stars of all.
And then we're gonna go over Chapter 6 in that NASA Life and Birth of a Star System series, and that chapter is called Aging into a Red Giant. So I just have some points from that article here that I'll go over. So, as our sun approaches its red giant phase, as we have talked about, it'll run out of fuel in its core. The core will get smaller as hydrogen fusion slows, leading it to heat up and kick off another round of nuclear reactions. This next round of nuclear reactions is the fusion of helium into heavier elements like carbon, nitrogen, and oxygen. Extra heat will cause the outer layer of gas to puff up, and they said that the end of a red giant phase is typically the most violent time in a star's life cycle. And here's a quote from astronomer Dmitry Veras from the University of Warwick. He said, "I am confident that the sun will swallow Mercury and Venus and not Mars, but the fate of the Earth, which resides in between, is less clear." And for some of you who may be worrying about this future fate of Earth, there's another quote from Mandel who said, We will all be long gone. Earth won't be habitable, and the only chance for survival would be for an advanced civilization to migrate to a new planetary home." I don't know if that's reassuring, but that's what we got.
Maybe.
And
So maybe it'll happen.
the um,
The advanced civilization.
migration.
Yeah.
Yeah, maybe. But either way, we won't be here when it turns into a red
Yeah.
giant, so
Oh yeah,
it won't
we'll all be
affect
dead.
us. Yeah. I don't know if that's a reassuring fact for people, but it's just the truth of the matter. So the planet's orbits may also become unstable during this time. As the red giant loses mass, the gravitational hold it has on planets becomes weaker. In our own solar system, the sun will throw off about half its mass, so the outer planets' orbits will drift outward, settling twice as far as they are today. Neptune, at 30 times the Earth sun distance, will eventually hike out to about 60 times the Earth sun distance. So, with that, I just have their video here from that series that I just wanted to briefly show. Let me get it going here. So, again, from NASA Solar System, Life and Death of a Planetary System, Chapter 6. And I don't think this one has sound either. That poor planet.
Oh no.
Okay, so that was that one. I think. Yeah, so that was just the, again, NASA series. That was chapter 6 of that series.
Yeah, so let's talk a little bit more about red giants. So a red giant is a luminous giant star of lower intermediate mass and a late phase of stellar evolution. The outer atmosphere is inflated and tenuous, making the radius large and the surface temperature around 5,000 Kelvin or lower. Once at the red giant stage, a star might stay that way for up to 1 billion years. Then the star will slowly contract and cool to become a white dwarf. Earth-sized, ultra-dense star corpses radiating a tiny fraction of their original energy. So, a red giant forms after a star has run out of hydrogen fuel for nuclear fusion and has begun the process of dying. The star maintains its stability through a fine balance between its own gravity, which holds it together, and the outwards pressure from ongoing thermonuclear fusion processes taking place at its core.
And then we'll briefly mention what a red supergiant is. So, red supergiants are stars with a supergiant luminosity class of spectral type K or M, and they are the largest stars in the universe in terms of volume, although they are not the most massive or luminous. So then I have another brief little article here from, again, NASA. This is called The Symphony of Red Giant Stars. So, using observations from NASA's Transiting Exoplanet Survey Satellite, or TESS, astronomers have identified an unprecedented collection of pulsating red giant stars all across the sky. TESS primarily hunts for worlds beyond our solar system, also known as exoplanets, but its sensitive measurements of stellar brightness make TESS ideal for studying stellar oscillations, an area of research called asteroseismology. So I have another video here, and I'll just read like the description of what the video is. So this video is going to show, this visualization shows the new sample of oscillating red giant stars, the colored dots discovered by NASA's TESS. The colors map to each 24 by 96 degrees swath of the sky observed during the mission's first 2 years. The view then changes to show the positions of these stars within our galaxy, based on distances determined by ESA, or the European Space Agency's Gaia mission. The scale shows distance in kiloparsecs, each equal to 3,260 light years, and extends nearly 20,000 light years from the sun. So we'll watch that video here. I'm not sure if this one has sound. We'll find out. I don't think it does.
Interesting.
Okay. So that was that video. And then I have one more video from that article, and this one will have sound. So, and I'll just, again, give a brief description of the video. So, listen to the rhythms of three red giants in the constellation Draco, as determined by brightness measurements from NASA's Transiting Exoplanet Survey satellite. To produce audible tones, astronomers multiplied the oscillation frequencies of the stars by 3 million times. It's clear that larger stars produce longer, deeper pulsations than smaller ones. So let's listen to some music produced by stars.
The last one just sounds like someone kind of messed up the mic, honestly.
Like like this type thing, or
Yeah, or like they were
okay.
messing with the mic or something. Yeah, but it's
Yeah, it's
interesting. I
interesting.
wonder what makes them have different tones. Is it the size or?
I think that is from what at least that's what I understood from how they were explaining it,
Okay,
would be, I guess, I
that
mean,
would
we
make
can,
sense.
Yeah, because I guess then they're gonna have different like fusion reactions going on based off of their different sizes.
Yeah,
Even like even red giants, because I don't think every red giant is the exact same size, correct? Like they
right.
can be a
And
little, there
I
could be
wonder,
variation.
yeah, and I wonder if like they're all perfectly like circular, so to speak, with their matter, or if it's kind of like, maybe there's like a little dent or something,
Yeah.
you know, like not a big dent, but just like little
No, I know. Yeah, like a
things, like
little
a perfectly perfect.
curvature. Yeah,
You're right, because I mean,
I
yeah,
would assume there would. I would be very surprised to learn if every single star was a perfect sphere, like without any
yeah,
minor indent or not big, but even just like a. I'd be surprised if we were to draw a circle around the
mm,
star if every star was exactly circular and the same
right,
without any
and like
alteration,
perfectly spherical.
Yes, yeah. I would be. I'm not going to say it's not, but I would be surprised.
Right. That's yeah, I would think the same thing. So, all right. We learned about red giants and super red giants. So, in our next video, we're going to move on to planetary nebula and supernova.
And as always, you can leave a comment below if you have any ideas for on future topics that you would like us to talk about in future episodes.
You can reach out to us on Facebook, YouTube, Instagram, Twitter, and TikTok. And we also occasionally do some Twitch live streams.
So don't forget to like, follow, or subscribe and turn on notifications so that you know when we do. Otherwise, we will see everyone in the next video.